Mhm. Hi guys, good morning everyone. Good morning. Online students, am I audible? Please confirm in the chat box. Yeah, perfect. Guys, in the last session, we discussed about what is monolith architecture, what are the drawbacks with monolithic architecture. Today, we are going to understand microservices architecture. So monolithic architecture, nothing but if you develop all the functionalities in one single application, then that is called monolithic architecture. If you go for monolithic architecture to develop the project, there are some drawbacks available. That is single point of failure, redeploying the entire application, maintenance of the project, then burden on the server. To overcome these problems available in monolithic architecture, people are developing projects by using microservices architecture. What is this microservices? Microservices is an design pattern, is an architectural design pattern. The main aim of microservices to develop our application with the loosely coupling. Okay. Now, so the definition for microservice nothing but it is independently deployable and executable service. So what are the benefits with microservices architecture? They are loosely coupled. Every service is independent, will be deployed into a separate server. As the functionality is divided into multiple services, the maintenance of the project also will become very easy and the load also will be distributed. When you go for microservices, the load also will be distributed and there is no rule that all the services we need to develop by using same technology. Every service is independent. Every service is a separate project. Technology independency also will be available when you go for microservices architecture. And another advantage, high availability. If one service is down, no problem. The remaining services will be up and running. And here, do I need to redeploy all the services if there is a change? No. So if any service having a change, only that particular service we are going to redeploy. We no need to redeploy all the services available in the application. Then when you go for microservices, there are some challenges also available. What is the first challenge with microservices? Bounded context, nothing but deciding number of REST APIs to develop our application. That is the difficult part. And the second one is duplicate configuration. So whatever the configuration we are doing for all the services, we need to do the same configuration. That is called duplicate configuration. And another problem is visibility. What is the meaning of visibility? You may not get the chance to work with all the services available in the project. You will be limited to some functionalities in the application. You don't know the complete application architecture. Okay. So these are the challenges available with microservices. Then what is architecture of the microservices? So for microservices architecture is universal, not only specific to Java people. Any technology people also can use microservices architecture to develop the application. Here, for the microservices, guys, there is no fixed architecture. That means people are customizing this microservices architecture as per their requirement. So there is no standard architecture to develop microservices project. So what components people are going to use to develop microservices? So the first one is service registry. Okay. So using service registry in the project is not mandatory, but recommended. Some people will use it. Some people will not use it. Same concept for admin server, Jipkin server, and API gateway, PN client, config server, Kafka, Redis, and Docker. So if you know these concepts, then we can say that we know microservices development. So let us see the architecture for microservices. When we are developing microservices, first we are going to take one component called service registry. There will be a component called service registry. Some people will also call service registry as a discovery server. Some people will call service registry also as a discovery server. To develop service registry or discovery server, we are going to use a concept called Eureka. There is a concept called Eureka. Eureka server we are going to use as a service registry. Some people will call Eureka is acting as a service registry. Some people will call Eureka is acting as a discovery server. Both are correct. So service registry is available. What is the purpose of this service registry in our project? Service registry will maintain list of services available in the project. So when we go for microservices, multiple services will be available. What all the services available in our project? What is the name of the service? What is the URL of the service? What is the status of the service? That means, is that service is up and running or not? All the services information will be maintained at one place, that is called service registry. Service registry is used to maintain list of microservices available in the project. For example, hotels API, trains API, cabs API, flights API. There are 4 APIs available. What is the names for those APIs? What are the URLs of those APIs? What is the status? That means whether that API is running or not running, that information about services will be maintained by service registry. So how do we work with the service registry? We are going to use Eureka as a service registry for our application. Okay. Then after, people will be using one more server, that is called admin server. There will be a server called admin server. What is the purpose of this admin server? Admin server is used to access actuator endpoints of our services. Already we discussed about actuators. What is the purpose of actuators? They are used to manage and monitor our application. Actuators are used to monitor and manage our application. So now there are 20 microservices available. For 20 microservices, actuators will be available. Managing 20 microservices by using actuators separately is a difficult process. I want to manage all the microservices actuators at one place. That's where admin server comes into picture. Service registry will maintain the names of the services, URLs of the services available in the application. All those services I want to monitor at one place. Every service having actuator, every service having different URL. Accessing every service and actuators separately will become difficult for the programmer. What I want to do is, I want to monitor all the APIs, all the microservices, actuators at one place. That's where admin server comes into picture. So can you tell me what is the purpose of admin server? To monitor and manage all the microservices at one place. That means for every microservice, actuator endpoints will be available. Accessing them separately, individually will become difficult. I want one common platform where I can monitor all my microservices. That's where we are going to use admin server. And the next one, we are going to use a concept called Zipkin server. There will be another server called Zipkin server. The purpose of Zipkin server is used for distributed tracing. Zipkin server is used for distributed tracing. Distributed tracing nothing but which request is going to which microservice. Now I'm accessing my e-commerce application. In the e-commerce application, there are 50 microservices available. My request processed by how many microservices in the backend? What is the time taken by microservice to complete my request processing? So that performance monitoring of microservices we can understand by using a server called Zipkin server. Admin server to manage and monitor all microservices actuators at one place. Service registry is used to maintain list of services available in the project. Then Jipkin server. Jipkin server is used for distributed tracing. What is the meaning of distributed tracing? Identify how much time taken by microservice for execution. I have sent one request. I sent a login request. Okay. So from UI, request will go to backend. In the backend, which microservice is executed? What is the time it has taken to process that request? How many microservices involved in the request processing? All that information you can get by using Jipkin server. Are you guys clear? So 3 servers we are going to use. One is Eureka server. Second one is admin server. Third one is Jipkin server. Can you tell me what is the purpose of Eureka server? Eureka is acting as a service registry or discovery server. What is the purpose of that Eureka? It will maintain list of services available in our application. Then admin server. What is the purpose of admin server? Admin server is used to monitor and manage all microservices at one place. Okay. Then Jipkin server. What is the purpose of Jipkin server? It is used for distributed tracing. What is the meaning of distributed tracing? What is the meaning of distributed tracing? Identify which services processed our request. What is the time taken by each microservice to process the request? So now here, my request processing done by 4 microservices, guys. I clicked on one button from the UI. In the background, 4 microservices executed. In these 4 microservices, which microservice is taking more time to process the request? My response is coming slow. If the response is coming slow, some microservice taking more time. Out of 4 microservices, which microservice is taking more time to process the request? That we can trace by using Jipkin server. Are you guys clear? Next one. We are going to develop backend APIs. Our REST APIs will be available. So let me call my REST API 1. Okay. API 1. We will call this API 1 as a microservice. So similarly, we will be having API 2. API 1 is available. API 2 is available. Like this, you can develop any number of APIs required for your application. These are actual backend services, payment service, portal service, or payment API, portal API. Like this, you can develop multiple APIs. These are our REST APIs. These are our REST APIs. So we can have multiple REST APIs in our application. We can have multiple REST APIs in our application. Okay. How many REST APIs we are going to develop? It depends on the requirement. How many REST APIs we are going to develop? That is depends on the requirement, guys. Okay. So these are our backend APIs. Okay. Service registry is available. Then Jipkin server is available. Admin server is available. Okay. And we are developing our backend APIs. What is the meaning of backend APIs? They contain some business logic. Every API is independently deployable, independently executable. Flights API, portals API, cabs API, trains API, payment API, admin API, report API, login API, like that. Depends on the requirement, n number of APIs we are going to develop. Those APIs are called as backend services. We are also calling them as microservices. Multiple names. Sometimes I'm calling as REST API. Sometimes I'm calling as backend API. Sometimes I'm calling as backend service. Sometimes I'm calling as microservice. All are same. Nothing but one API which contains some functionality, which is responsible to do only one operation. Everything is not available in single project. We are dividing our functionalities into multiple APIs. are multiple services or multiple microservices. What is the meaning of microservice? A small service which is independently deployable, independently executable. Now, what are the backend APIs we are developing in our application? Those backend APIs will act as a client for the Eureka. Eureka is a server. Our APIs will act as a client for the Eureka. That means our APIs will register with the Eureka server. Our APIs will be registered with the Eureka server, and our APIs will act as a client for admin server. Our APIs will be registered with the admin server also. Our APIs will act as a client for Jipkin server also. Are you getting my point? No. Backend APIs can be any number. I am taking example for 2. These backend APIs will act as a client for Eureka server, will act as a client for admin server, will act as a client for Jipkin server. What is a Jipkin server? What is the purpose of Jipkin server? Jipkin server is used for distributed tracing. Jipkin server is used for distributed tracing. What is the meaning of distributed tracing? Identify how many APIs involved in the request processing. What is the time taken by each API to complete the request? Which API is fast? Which API is slow? That information we can get by using Jipkin server. Then what is admin server? Monitor and manage all the APIs at one place. Then what is Eureka server? What is Eureka server? Register all your APIs at one place. Now, our APIs acting as a client for Eureka server, acting as a client for admin server, acting as a client for Jipkin server. Clear? Now, when these APIs are available like this, there is a chance one API can communicate with the another API. One API can communicate with the another API. This is called inter-service communication. One API is communicating with another API. API 1 is communicating with API 2. This is called inter-service communication. For this inter-service communication, we are going to use a concept called FIAN client. What is the concept we are using, guys? FIAN client. What is the purpose of a FIAN client? FIAN client is used for inter-service communication. One REST API wants to communicate with the another REST API available in the same application. Within this application, we are having two APIs. One API is communicating with the another API. So this is called as inter-service communication. Okay, and here this API can communicate with its own database. This API also can communicate with its own database. So it depends on the requirement, whether our APIs are going to communicate with a separate database or our APIs are going to communicate with the same database. It depends on the requirement, guys. It depends upon the requirement. Some microservices may not use the database also. Some microservices may not use the database also. Like this, my APIs can communicate with the database. And I have a requirement that my API should communicate with one third-party REST API. So I want to communicate with some third-party REST API. So this is third-party. This is third-party API. API 2 is going to communicate with the third-party API also. Now, if you see API 2 acting as a provider as well as it is acting as a consumer. For API 1, API 2 is a provider. For third-party API, it is a consumer. It can communicate with the database and it can communicate with the third-party API also. Are you able to follow this? What is FIAN client here? What is FIAN client here? FIAN client is used for inter-service communication. What is the meaning of inter-service communication? one API is communicating with the another API, which is available in the same application. Okay, sir, can I do inter-service communication by using REST template? Yes, you can do that. Can I do that by using web client? Yes, you can do that. We have other option called PN client. In general, for the inter-service communication, people will go for PN client, guys. Okay, then my API 2 wants to communicate with the third-party API. For third-party API communication, again, three options. You can go with REST template, you can go with the web client, you can go with PN client also. PN client can be used for inter-service communication as well as for external service communication also. Are you able to understand? Then fine. So like this, we are going to develop all these APIs. For example, my API 2 is getting many requests. So many requests are coming to API 2. People can access API 2 directly. API 1 also accessing API 2. So the load is increasing on the API 2. The burden is increasing on the API 2. When the burden is increasing on the API 2, what we do is we are going to implement load balancing. What we are going to do, guys? We are going to implement load balancing. So here you can see there two boxes available. Nothing but API 2 is running in two servers. If I run the API 2 in one server, then what will happen? All the requests will go to single server. Then burden will be increased on the server. So that's why in the real time, every application will be deployed into multiple servers. Instead of running the application in one server, we will run the application in multiple servers. Those are called as instances. Those are called as instances. Same application will run in multiple servers. Those are called instances of the microservice. My microservice is having 3 instances. What is the meaning of that? My microservice is running in 3 servers. Why we are running our microservice in 3 servers? For the load balancing. So now API 1 should access API 2. API 2 is available in one server. API 2 is available in 2 servers. 2 servers. Depends on the situation. I can run my API 2 in 10 servers also. If more load is coming, my API 2 will be running in the 10 servers. When API 2 is running in the 10 servers, how API 1 will communicate with the API 2? That's where PN client will play very important role. If you go for REST template, if you go for web client, we need to configure the server URL to access the API. But here, one server is available or 10 servers available. Are you guys getting my point? So we are using REST template. If you go for REST template, what we need to do? Configure the URL. If I go for web client, what I need to do? Configure the URL. How many URLs you can configure in the REST template? One URL. In the web client also, one URL. But here, one URL is available, 10 URLs available, 10 URLs available. Always you will use same URL or every time you need different URL? Are you guys get that is called load balancing. The load balancing is the inbuilt functionality when you go for PN client. If you go for REST template, if you go for web client, load balancing is not available. Always it will talk to the same server with the same URL. But my application is not running in the single server. My application running in the 10 servers. 10 servers are having 10 different URLs. Then how API 1 will access API 2. API 2 is not one server. API 2 running in the 10 servers. So first request should go to first server. Second request should go to second server. Third request should go to third server. In the round robin fashion, the request should go to API 2. That's where load balancing is required. So here, the main benefit with the PN client is inbuilt load balancing is available. The main benefit with the FIAN client, inbuilt load balancing is available. Are you guys able to follow me? Now, so if you see our last application, here what we have done, we are configuring the URL. Which URL we configured? One URL we configured. If you have only one instance for your microservice, one URL will be available. Then you go with the REST template or you go with the web client. It's up to you. But in the real time, microservices will have multiple instances. Why? What is the meaning of multiple instances? One API will run in multiple servers. So every server will have its own URL. Every server will have its own URL. Then how API 1 will access API 2, which is having multiple instances. That's where we are going to use FIAN client. What is the benefit with the FIAN client? Load balancing. The benefit with the FIAN client is load balancing. Earlier, when we use web client or REST template, we are configuring URL to access our API. Like this, we are configuring the URL to access our API. But now in the microservices, when we want to access one API from the another API, we should not use the URL. Why we should not use the URL? It is not one URL. It is 10 URL. Today it is 10. Tomorrow it may be 20 or tomorrow it may be 5 only. Depends on the situation. I can increase the instances. I can decrease the instances. So dynamically, FIAN client will communicate with the API 2 by getting the URLs from the service registry. Who will maintain the URLs of our services? Who will maintain the URLs of our services? Service registry will maintain the URLs of the services. So observe this very important concept. REST template, web client, FIAN client. REST template, service, one service can access another service. Okay, but it is synchronous. Web client, synchronous plus asynchronous. But what is the problem with them? Hard-coded URL. Which API you want to access, you need to hard-code that API URL. So if you have one URL, that is okay. But my microservice is having 10 URLs. So how do you use web client with 10 URLs? Not possible. So you need to give any particular URL. Always request will go to same URL, same server, burden will be increased. To reduce the burden, I'm running my API in multiple servers. So here for this API 1, want to access API 2, don't use the REST template, don't use web client. Why? Because they will use a single URL to communicate with the same server every time. But I want to distribute the load. That is the reason API 2 I am running in multiple servers. So here for this communication, I will use FIAN client. What I will tell to the FIAN client is, hey FIAN client will be available in the API 1 because API 1 want to access API 2. API 1 want to access API 2. So FIAN client will be available in the API 1 or FIAN client will be available in the API 2. API 1 only. Why? API 1 want to communicate with the API 2. So FIAN client will be available in the API 1. What we need to tell to FIAN client? Communicate with the API 2. But API 2 is one instance. API 2 is 10 instances. API 2 is 10 instances. Today it is 10. Tomorrow it can be less than 10. It can be more than 10. So URLs are not fixed here. URL can change at any point of time. Number of URLs can be increased. I mean to say, number of instances can be increased. Number of instances can be decreased. When we are going for inter-service communication, what we will do is, for the FIAN client, hey FIAN client, I want to communicate with the API 2, but I don't know URL of the API 2. This FIAN client should communicate with the service registry to identify URLs of the API 2. FIAN client will go to the service registry and FIAN client will tell to service registry, hey service registry, I want to access API 2. Can you tell me URL of the API 2? Service registry will identify how many URLs available for the API to, then service registry will give the URLs to the FIAN client. Hey FIAN client, I have 10 URLs for the API to. Then FIAN client should take the decision which URL it has to use to communicate with the API to. That's where FIAN client internally will be using one concept called ribbon concept. Internally, FIAN client will be using a concept called ribbon concept. Why this is going to use the ribbon concept? FIAN client will use the ribbon concept to decide which URL it has to use to communicate with the API to. API 2 is having 10 URLs. Out of 10 URLs, you take first URL for the first request. You take second URL for the second request. You take third URL for the third request. Who will decide that? Ribbon will decide that. Are you getting my point? Why we are going for FIAN client, guys? Inter-service communication. Inter-service communication will happen with the service URL or with the service name. Service name. Service name. Because URLs can increase, URLs can decrease. Service name is not going to change. Service name is not going to change. So when you are using this FIAN client for inter-service communication, API 1 will tell to FIAN client, hey FIAN client, go and get the API 2 data. But where is API 2? Who knows where is the API 2? What is the URL of the API 2? I don't know. My FIAN client also don't know. Who will maintain all the services details? Service registry. Okay. FIAN client will ask service registry, hey service registry, where is API 2? What is the URL of the API 2? Then service registry will give the URLs to the FIAN client. Then FIAN client will take the decision to access API 2 by using which URL. So that is the reason people will call Eureka as a discovery server. Why they are calling as a discovery server? It is used to identify URLs of the services based on the name of the service. So I will go to FIAN client. FIAN client will go to service registry. FIAN client will ask, boss, I want to talk to API 2. Then service registry will give, these are the URLs of the API 2. Then FIAN client will use a ribbon. Ribbon will decide which URL we need to use because there are 10 URLs available. Out of 10, you take one URL and you communicate with the API 2. If I go for web client, only one. Always the request will go to same server, burden will be increased. Now you understand why it is called discovery server. Why it is called discovery server? It is used to identify services based on the names. By using service name, we can get the service URL. Service can have one URL, service can have multiple URLs. What is the meaning that service is having multiple URLs? That service is running in multiple instances. Why we need to run our service in multiple instances? For the load balancing. For the load balancing. Are you guys clear? Good. Tell me, what is Eureka? Come on, what is Eureka? Eureka is a service registry and it is also called as discovery server. What is the role of service registry in the microservices? It is used to register the services. It is used to identify the services. So all the services available in the application, you can discover at one place. That is called service registry. What is admin server? What is admin server? It is used to monitor and manage all our services at one place. Okay, so every service will have actuator. Accessing actuators of all the services individually difficult. I need one platform, one common platform where I can access all the endpoints of the services. That's where admin server comes into picture. Next one, Jipkin server. What is the purpose of Jipkin server? What is the purpose of Jipkin server? Distributed tracing. Which service taking more time? Which service taking less time? How many services executed for one request processing? All that data we can get from Jipkin server. Then what is the FIAN client? FIAN client is used for inter-service communication. What is the meaning of inter-service communication? One service will communicate with the another service. Why only FIAN client? Why not REST template web client? With the FIAN client, we are going to get the load balancing. Okay. Any microservice which is having more demand, which is getting more requests, for that microservice, we will create multiple instances. What is the meaning of creating multiple instances? Running in the multiple servers. So for every server, one URL will be available. Now, when API 2 running in multiple servers, load should be distributed. First request go to first server, second request go to second server. In all the servers, same project, same API, same logic will be available. How FIAN client will do the distribution? FIAN client will not know the URL of the API 2. Who will maintain the URLs of the APIs? Service registry. API 1 will tell to FIAN client to talk to API 2. FIAN client will go to discovery server, get the URLs of the API, then communicate with those URLs. So to do that load balancing, FIAN client internally using a concept called ribbon. Are you clear? Now, how many databases will be available in our application? There are two APIs available. That means, do we need to use two databases? It's not mandatory. Depends on the situation. Sometimes every API will have its own database. Sometimes multiple APIs will share the common database. Sometimes one API will communicate with two different databases also. It's all depends on our project requirement. Okay, good. Then next one. Here API 1 is available and API 2 is available. Okay, like this, assume that I am having 10 APIs in my project. I'm having 10 APIs in my project. For these 10 APIs, I want to implement some security. For 10 APIs, I want to implement some security. So writing security logic at 10 places, waste of time. I want to implement some security for my APIs. So implementing security for 10 APIs separately is a duplicate code. Okay. So same duplicate configuration we are going to do. So to avoid that problem, to avoid that duplicate security logic, we need a single entry point for our microservices. Okay. So your house will have multiple rooms. For all the rooms, one main gate will be available. If you want to enter into your house, first you need to cross the main gate. Then you can go to any room available in your house. Similarly, for all these microservices, single entry point should be available. Security check should be available at one place. Are you guys able to do that? Understand? Now, in order to manage or in order to secure all these microservices at one place, we are going to use a concept called API gateway. What is the concept, guys? API gateway. What is this API gateway? API gateway is the entry point for all the APIs in our application. API gateway will act as a mediator between UI application and backend APIs. So UI project is separate, backend APIs are separate. If UI project want to access our backend APIs, that request should come through API gateway. API gateway is used to manage backend APIs. So it is providing single entry point for all the APIs available in our application. So tell me, what is API gateway? API gateway is used to manage all the backend APIs. So in the Spring MVC, dispatcher servlet is a front controller. Every request will go to dispatcher servlet. From there, handler mapper, controller, view resolver. Similarly, if anybody want to access any backend API in our application, they should access our API gateway. Our API gateway will decide whether to process that request or not. Now, my project is having 10 URLs. My project is having 10 microservices. I will not give you 10 URLs for 10 microservices. I will give you one URL for accessing my microservices. Which URL I will give you? API gateway URL. You send a request to API gateway. My API gateway will decide whether to process your request or not. Your request should go to which API will be decided by my API gateway. API gateway is an entry point for backend APIs. It acts as a mediator between incoming request and backend APIs. You send a request for my application. My application is a microservices application. In the background, there are 50 microservices available. But do you know all the 50 URLs of my 50 microservices? I will not tell you. I will give you single URL. What is that single URL? API gateway URL. Your request will come to my API gateway. My API gateway will verify your request is a valid request or not. If your request is a valid request, then my API gateway will decide your request should be processed by which microservice. That is called routing. Request will be routed to backend microservices. That routing logic will be available in the API gateway. What is the meaning of routing? What is the meaning of routing? It will identify which request should be processed by which microservice, then forward the request to that particular microservice. Routing logic will be available. Along with the routing, in the API gateway, filters also will be available. What is a filter? To verify your request, whether you are a valid customer or not, whether you are my consumer or not, that will be decided by API gateway. So in the API gateway, mainly we are going to implement two concepts, guys. In the API gateway, mainly we are going to implement two concepts. What are those two concepts? One is filters and the second one is routing. Filters will be available, routing will be available. What is the meaning of the filter? Filter is used to secure our APIs. So whatever the request you are sending, whether your request is a valid request or not, I will execute a filter for that. Suppose your request is invalid. Your request is invalid. Then the API gateway will stop your request at the main gate only. API gateway is acting as a main gate for backend APIs in our application. Okay. If your request is valid, then API gateway will execute routing. What is the meaning of routing? It will forward your request to particular API available in the project. A project can have 20 APIs, 30, 40, 100, 200 also. So those APIs will be executed based on the request forwarded by API gateway. API gateway is the entry point for all the APIs of our application. It is used to manage all our APIs, common logic, any filter, any security, any routing that is required. The common logic that are required for multiple APIs, we are going to keep in the API gateway. So what is entry point for microservices application? API gateway. So if third party people want to access our API or UI application want to access our API, first they need to access API gateway. Then API gateway will decide whether to process that request or not. If the request is valid, then it will route the request to particular microservice. If the request is invalid, it will stop the request. It will send error message to the client. So this is microservices architecture, but this is not the standard architecture. Most of the people in the companies will follow this architecture to develop the project with microservices. But here there is no rule that we need to use a service registry. It's not mandatory, optional. There is no rule we need to use admin server. There is no rule we need to use Zipkin server. There is no rule we need to use API gateway. There is no rule we need to use PN client. All these things which I have marked, these are optional but recommended to use in the project. Some people will develop only REST APIs. No service registry, no admin server, no Jipkin server, no PN client, no API gateway. Still, they will call it as microservices project because they developed REST APIs. Every functionality available in the separate REST API, only 10 REST APIs they develop. Still, they will call microservices project. So that is what. There is no standard architecture available for the microservices. People are customizing microservices architecture according to their requirement. Some people will use service registry. Some people may not use a service registry. Some people will use a PN client. Some people may not use PN client. Some people will use API gateway. Some people will not use API gateway. Are you guys able to follow me? And along with these things, our microservices available, right? What our microservices will do in the real time? In the real time, our APIs will communicate with the Kafka. Our APIs are going to communicate with the Kafka. Kafka is called message broker. My one API want to send some data to another API, but not with the communication. One API want to give the data to another API. Simple example. You are booking biryani in the Swiggy. You are sending a request to the Swiggy to order food. When you book the food in the Swiggy, Swiggy will send you a message to delivery boy. Are you getting my point? If you book a cab in the Uber or Ola, the request will go to driver. So here, this is called event-driven architecture. So one API will send the information to another API by using Kafka as a message broker. If you are working with microservices, then Kafka will play very important role. Apache Kafka. Along with Kafka, in our projects, we are going to use Redis. We are going to use Redis. Redis we are going to use as a cache. There is some static data in our application. There is some data in my database which is a static data. For example, countries. All APIs want to get the countries data. Countries data will change every day. No, it is a static data. That static data required for all the APIs. Okay. So instead of communicating with the database every time to get the static data, we are going to maintain the data in the cache. That cache is a distributed cache. What is the meaning of distributed cache? Multiple APIs can access the same data from the cache. That's where we are going to use Redis in our application. Redis will be available for our application. Kafka is acting as a message broker. Redis is used for distributed cache. Along with these things, our microservices will talk to one more component which is called config server. One more component will be available which is called config server. Sir, what is this config server? Config server is very important in the microservices. What is the role of this config server? As of now, if you see any application we are developing, in our application, we are configuring data source properties within the properties file. Okay, either properties file or YML file. We are keeping our data in the properties file or YML file. Tomorrow, if I want to change the database, if I want to change my database, I need to change the properties file or YML file, recompile the project, repackage the project, re-execute the project. That is a tightly coupling. My application is tightly coupled with the properties. Okay, that is not accepted in the real time. So in the real time, properties will be available outside of the project. Currently, where the properties available? Properties available inside the project. If you keep the properties inside the project, that is a tightly coupling. Tomorrow, I want to deploy my application into another database. I want to deploy my application into SIT environment. Currently, my project is in the dev environment. I want to deploy the project into SIT. If you want to go for SIT, database will be changed. If the database is changed, what we need to do? Again change the properties, again compile, again package, again run the application. Are you getting my point? So that is tightly coupling problem. Currently, as of now, we are keeping properties within the YML. That YML or properties file available within the project. So tomorrow, our properties will be available outside of the project. Are you guys getting my point? Whatever the database properties, whatever SMTP properties, messages, Kafka, Redis, any properties that you want to use in the application, you need to separate them from the project. How do we separate them from the project? That's where config server comes into picture. By using config server, we can load application properties from outside, not from inside the project. So as of now, till today, we are writing the properties within the application. But in the real time, properties will be available outside of the application. So to load the properties from outside of the application, we are going to use config server concept. So when we are using microservices, this kind of config servers will be available. In general, properties will be available in the GitHub repository. Project will be available in one repository. Properties will be available in the another repository. So properties repository, API repository. Who is the mediator? Config server. My API will talk to config server. Config server will talk to properties file or YML file. So as of now, we are writing properties within the application. But going forward, we need to separate the properties from the project. Whatever the database you want to connect, you need to load the database data from outside of the project. For that, we are going to use config server. What is Kafka? Kafka is a message broker. What is the purpose of this message broker? What is the purpose? Why we need a message broker? What is the use of this message broker? What is the use of this message broker? Come on, guys. This message broker is used to send the data from one application to another application. Okay. What is Redis? Redis is a distributed cache. Why we need distributed cache? Why we need distributed cache, guys? Any common data you want to use in all the APIs, then you will keep that common data in the Redis cache. Then what is a config server? What is the purpose of config server? To separate application and application properties. To separate application properties, we are going to use config server. So config server is used to externalize configuration properties of the application. So whatever the properties we are writing within the application, we need to keep them outside of the application. Why we need to keep them outside of the application? Loosely coupling. Tomorrow, if properties changed, I no need to recompile the project. I no need to repackage the project. Properties always should be outside of the project. For that, we are going to use config server. Yes, our microservices, our backend APIs can communicate with Kafka, can communicate with Redis, can communicate with the config. Again, all these three mandatory? No. Again, depends on the project. But in most of the projects which I have seen in the microservice architecture, Kafka is there, Redis is there, config server is there. Kafka is used for message brokerage. It is a message broker. So earlier people worked with RabbitMQ, ActiveMQ, JMS kind of thing. But nowadays people are going for Apache Kafka. Redis cache is available. In some projects, instead of Redis cache, they will go for Gemfire cache also. Gemfire cache is also available. but nowadays Redis is more famous than Gemfire, and people are using config server to externalize properties of our application. So this is microservices architecture. Look at this diagram. Now, incoming requests will come to API gateway. That request may be from third-party application, may be from UI application. UI application want to access backend applications, backend APIs. UI application will send a request to API gateway. API gateway will execute a filter and will execute routing. Service registry, which is acting as a discovery server. Service registry will maintain all the services which are available in our application. Online students able to understand? Config server will not register with the service registry, guys. So see here, whatever the arrows I have given, only those things will be registered. API gateway will register with the service registry. Our microservices will register with the service registry. Our microservice will register with the admin server. Our microservices will register with the Jipkin server. Is there any communication between Eureka and admin server? No. Is there any communication between Eureka and Jipkin server? No. Is there any communication between Eureka and config server? No, they are independent. Someone is asking, when inter-service communication is already available, why you need to go for Kafka? We will discuss in the Kafka session what is the purpose of going for Kafka. Not able to understand the difference between service registry and admin server. Admin server will provide platform to access actuators of your APIs at one place. Service registry will just maintain what are the services, what are the names, what are the URLs, what are the statuses of those services. Admin server will give you platform to access actuators of your APIs. Both are different. Somebody not able to understand the difference. Unable to understand the FIAN client. What is FIAN client? It is used for almost I explained for 30 minutes about the FIAN client. It is used for inter-service communication. If one API want to communicate with the another API, then we will use FIAN client. Actually, how many options we have? 3. If one microservice, one REST API want to access another REST API, you can go with REST template, you can go with web client, you can go with FIAN client. But what is the problem with REST template web client? They need fixed URL. But here URLs are fixed or URLs are not fixed? Not fixed, because I am going for microservice with multiple instances. So that is the reason I will go for FIAN client. When I use that FIAN client, what is the benefit? Load will be distributed. FIAN client will talk to another service by using service name, not with the service URL. Who will maintain the service URLs? Service registry. API 1 will access FIAN client. FIAN client will access service registry. It will give the URLs of the service. Then it will communicate with the API 2. FIAN client is Spring Cloud concept, which is used for inter-service communication. Very good. Not understand. Kalyani, what you did not understand? Why 2 boxes in API 2? I think these people joined. Okay. Guys, why 2 boxes? These 2 boxes represents that it is running in 2 servers, guys. Okay. Guys, here API 1 is having 1 box. Nothing but it is running in 1 server. It is 1 instance. API 2 having 2 boxes because I'm running in 2 servers. Nothing but load will be distributed. Instead of giving the load for 1 person, we are distributing the load to 2 persons. So that's why we are running the API 2 as 2 instances. Same project will run in 2 servers. So 2 boxes, nothing but 2 instances. Okay. Forget about Kafka, Redis, config server. Just remember that microservices will use Kafka, will use Redis, will use config server. We have separate classes for them. What is Kafka? How to set up Kafka? How to work with Kafka? We are going to understand in the coming classes. What is Redis? How to set up Redis? How to work with Redis? 2 days we are going to spend for only Redis. 2 days we are going to spend only for Kafka. 1 day class completely for only config server. So just these are titles. Just these are titles. So going forward, we are going to understand in depth about what is Kafka, what is Redis, what is config server, how to use them in our project. By using all these things, we are going to develop a project. Whatever theory we discussed today, everything we are going to implement practically in our course. Got it? So if anybody is saying that, sir, I did not understand Redis, I have not explained anything about Redis. Just I told Redis is used for cache. That's it. If you remember that point, that is sufficient for today. So in the coming sessions, we will spend 2 classes only for Redis. That day you will get the clarity. What is Redis? Why we need to go for Redis? Suppose if I say Kafka, sir, I'm not able to understand what is Kafka. Just to remember, Kafka is a message broker. That's it. That's it. That is sufficient. That is sufficient. In the coming classes, we will work on Kafka. That day I will give brief introduction. What is Kafka? Why Kafka? How to work with Kafka. Config server. For time being, what we should know about config server? To separate properties from our application. That's it. That's it. PN client. Inter-service communication. Sir, how PN client will communicate without URL? That is upcoming class. Practically, we will do that. Coding we need to do for that. Admin server. So remember, it is used to access actuators of all the APIs at one place. Jipkin server. What is the purpose? Tracing. How do we do the tracing? We have not seen that. Just titles I have given, diagram I have given. So just remember, API gateway, entry point for the backend APIs. API gateway will act as a mediator between incoming requests and backend APIs. Inside the API gateway, filter will be available, routing will be available. So every request coming to our application will go to API gateway. It will do the filter, it will do the routing. Then what is Eureka? Eureka is a service registry. What will be there in the Eureka? How many services are there in our project? It will maintain the list of those services. Name of the service, URL of the service, status of the service. Okay. Then next one, admin server. Admin server for actuators, guys. Actuators we can access separately. If I have 100 APIs, accessing 100 API actuators individually difficult. I need one platform where I can access all the actuators of all the APIs. That's where admin server. Jipkin server. Tracing. Which API taking more time to process the request? How much time taking by each API to process the request? How many APIs involved in the request processing will be given by Jipkin server. The next one, API 1 and API 2. These are actual microservices. Our REST APIs, our REST controllers will be available. Every API is responsible for separate functionality. These APIs are independently deployable, independently executable, independently testable also. Now, our API 1 and API 2 will register with Eureka, will register with admin server, will register with Zipkin server. So our APIs acting as a client for Eureka, acting as client for admin server, acting as client for Zipkin server. Then if there is a requirement, I want to communicate from one API to another API. That is called inter-service communication. That inter-service communication we can do in three ways: REST template, web client, PN client. REST template web client needs the URL of the API to communicate. But here my API will not run in one server because of load. I will run my API in two servers. Nothing but two instances will be available. So API 1 should access API 2, which is running in two servers. How to access API running in two servers? Round robin. Round robin means first request go to first server, second request should go to second server, third request should go to first server, fourth request should go to second server. That is called round robin technique. How that round robin technique will happen? With the PN client. Directly I will not give the URL for the communication. I will use PN client. PN client will use name of the service. With that name, PN client will get the URLs from the Eureka. Based on the URLs, PN client will communicate with the API 2. So to decide which request should go to which server, PN client will take the help of Ribbon. Ribbon will decide that round robin technique here. Okay. Then my microservices can communicate with third-party APIs also. When they are communicating with third-party API, they can go with REST template, they can go with the web client, they can go with the PN client also. And the next one, my microservices can use Kafka for message broker. My microservices can use Redis for the cache. My microservices can use config server to separate properties from our application. To make our application loosely coupled with the properties, we are going to use config server. Are you clear? Still, online people, anybody not able to understand? In place of Kafka, Kafka purpose is different, sir. Kafka purpose is different. We already have API gateway. We already have service registry. Why to go for routing in the API gateway? Service registry will tell you what is the API, what is the URL. It will not do the routing. Service registry will not do the routing. Who will do the routing? API gate. Service registry just like a register. Student number 1, number 2, student ID, student name, student status. Similarly, API 1, name, status, URL. It will just maintain list of services available in the project. Routing cannot done by using Eureka. Eureka will tell you what services available, whether they are running or not running, what is the URLs available for each service. It is just like a display. I already told you. Guys, online people, why you are asking same question again and again? What I told here. For third-party communication, how many options are there? For third-party communication also you can use PN client. Okay. Ribbon is a load balancer type, guys. So Ribbon, you no need to do anything with the Ribbon. You no need to do any configuration with the Ribbon. When you use a PN client, automatically Ribbon will be available. You no need to do anything separately for the load balancing. Okay. If you use a PN client, it will take care of the load balancing. Ribbon, internally it will use. We no need to configure that Ribbon. Vinoop, what is, I told you, forget about Kafka. Kafka is a future topic. I'm not talking anything about Kafka. Just keep in your mind, microservices will use Kafka. That's it. It is a message broker. Why, when, what, how, these are future lectures. Yeah. Any other questions? Balraju? Just now I told you, forget about these things. How load balancing will done in the REST template if you use it. If you use a REST template, then guys, load balancing basically two types. One is client side load balancing. Another one is server side load balancing. PN client will use client side load balancing, not the server side load balancing. When I go for load balancing topic, I will tell you what is the difference between client side load balancing and server side load balancing. When I'm going to explain the PN client, I will tell you about load balancing. That time you will get the clarity. If I use a REST template, how the load balancing will happen. If I use a PN client, how the load balancing will happen. What is the client side load balancing? What is server side load balancing? Which one is better? We will discuss in the load balancing topic. For service registry, good question. So here for service registry, we are using Eureka. Sir, do we have any other alternate for the service registry? Yes, there are several options available to work with the service registry. So one of the alternate for the Eureka, which is Consul. Consul is also going to act as a service registry. Consul server also we can use as a service registry. AWS service registry is available. Azure service registry available. There are several service registries are available. But from the Spring, we got Eureka as a service registry, which is free of cost. If you go for AWS service registry, we need to pay the money for the service registry. If you want to go with the free service registry, then Eureka is sufficient for that. And here for API gateway, we are going to use Joule. Joule is outdated. Okay, now we are having Cloud Gateway. Spring Cloud Gateway is available, which is going to act as a API gateway. Sir, I don't want to use a Spring API gateway. Is there any other API gateway is available? APG is another API gateway which is given by Google, which is a paid API gateway. So some free servers are available, open source servers available, paid servers available. Okay, so now I want to use API gateway in my application. API gateway earlier people used it to work with Joule as a API gateway. Now Joule is removed in the latest version of the Spring Boot. Okay, now Joule we can't use. What we can use now, the alternate for the Joule is Cloud Gateway. Cloud Gateway is given by Spring. If you don't want to use this Cloud Gateway, then you need to go for APG. APG is a Google gateway. Google provided APG as a API gateway, but it is a commercial API gateway. So we can't use that. So we are going to work with Cloud API gateway in our application, which is given by Spring Cloud, which is free of cost. What is the cluster management? Out of syllabus. RabbitMQ. That is also like Kafka. Kafka is advanced than RabbitMQ. ActiveMQ, RabbitMQ, these all are message brokers. Those are outdated. Currently in the market, people are going with Kafka as a message broker. Good. Fine, guys. Let's take a break for breakfast. We'll meet again at 9:30. Okay, it's 9 o'clock. Have your breakfast and come back. 9:30 to 10:30 or 11, we will continue our class. So in the next session, we are going to create a service registry. We will create admin server and we will create Zipkin server. We will register one API with this service registry. So whatever theory we discussed, we are going to implement practically in the next session. Okay, another 1 to 1.5 hour session we need. So now we'll meet again at 9:30. Okay, good guys. Thank you. Online people, any questions you have after the class? 9:30, I will take your questions. Then we will start the session. Okay, good.